Good morning children, welcome to your maths class with Poonam Bagga. We are studying chapter 3, playing with numbers. Up till now in this chapter we have learnt about factors and multiples of a given number. We also learnt about prime numbers and composite numbers. We now know that a prime number is a number which has only two factors. One factor is 1 and the second factor is the number itself. Also we now know that a composite number is a number that has more than two factors. In our previous class, we started exercise 3.2 and we did question number 1 to 6 of it. Today also we will be continuing with the same exercise and we will be taking up question number 7 to 12. So here is question number 7. Give 3 pairs of prime numbers whose difference is 2. Here we have to find 2 prime numbers. Pairs means, a pair means 2 numbers at a time. So we have to find 2 prime numbers whose difference is 2 and such prime numbers are called twin primes. 2 prime numbers whose difference is 2 are called twin primes. So this is new for you and now we will look out for such prime numbers whose difference is 2 and we have to find 3 such pairs. Okay. So we have these prime numbers from 1 to 100 with us and you should all learn these prime numbers. At least till 20 you should learn them very well. We have these prime numbers. Now we will look out for 2 prime numbers whose difference is 2. So we take up the first 2 numbers 2 and 3. What is their difference? Clearly 3 minus 2 is 1. So this is not satisfying our condition. So we will not take these 2 numbers. Then we look out for 3 and 5. What is their difference? Clearly 5 minus 3 is 2. So these are the 2 prime numbers whose difference is 2 and this is one such pair we are looking for. So we can write 5 and 3 is the first pair whose difference is 2. Then we look out for the second pair. Again you can see 5 and 7. What is their difference? 7 minus 5 is 2. So we got the second pair also 7 and 5. It's very easy. Then we look out for the third pair. Just have a look. If we take 7 and 11, what is their difference? 11 minus 7 is 4. It is not 2 and so we cannot take this and so these two are not twin primes. We now come on to 11 and 13. What is their difference? 13 minus 11 is 2. Yes, and so we can easily take these 2 numbers 13 and 11. So these are the twin primes and you can have many more such pairs. Just have a look 17 and 19, their difference is 2. Also 59 and 61, their difference is also 2. Just have a look 41, 43, their difference is also 2 and similarly you can get many more such pairs called twin primes. Okay. Now we get question number 8. Which of the following numbers are prime? Here a few numbers have been given. We will be checking whether it is a prime number or not. For this we will write down the factors of 23 because we know a number is prime if it has only 2 factors. Here also let us write the factors of 23. 1 is a factor of every number we know and 23 will be a factor of itself. So the second factor is 23. Now is there any other factor also of 23? How we will look out for it? We should just think that whether this 23 comes in the table of any number. क्या ये 23 किसी की टेबल में आता है, किसी नंबर की टेबल में? अगर आता है तो वो नंबर इसका फैक्टर हो जाएगा और नहीं आ रहा है तो इसका और कोई फैक्टर नहीं है. Now we know that 23 is not there in any of the other numbers table. So there are only 2 factors of 23, 1 and 23 and so we can say that it is a prime number because a prime number has only 2 factors. So we write here since 23 has only 2 factors Therefore, this is the symbol for therefore, 3 dots in this way, and this symbol represents since. So, therefore, 23 is a prime number. Got it? Then we have this number 51. Again we will write down the factors of 51 first. We know that 1 is a factor of every number and 51 will be a factor of itself. And do we have any other factors also? Just think about it. Yes, if we divide this 51 by 3, what do we get? It's 3 ones are 3, 2, 1, 3 sevens are 21. Oh yes, 3 is dividing 51 completely, and so 3 is a factor of 51. So we have this factor 3 also, and since it's 17 times 51, so 17 will also divide 51 completely, and so 17 is also a factor of 51. So these are the factors of 51. Now what number is this? Is it prime? No, it's a composite number now, because it has more than 2 factors. So it is a composite number and not a prime number. And so we write here, since 51 has more than 2 factors, or you can say 4 factors, therefore 51 is not a prime number. Here we have been asked that which of the following numbers are prime. So that's why the answer is in the same language, that 51 is not a prime number. Okay. Then we have 2 more numbers. Let us have them. 37. Again we have to check whether 37 is a prime number or not. So first of all we will write down the factors of 37. Just think about it. 1 is its factor and 37 is a factor of itself. Now just think about it, that this 37, does this number comes in the table of any other number? No, 37 is not there in any other numbers table. 37 किसी और नंबर की टेबल में नहीं आता है. तो इसके 2 ही फैक्टर्स होंगे, एक तो 1 और एक 37 खुद अपना फैक्टर होगा. So there are only 2 factors, 1 and 37, and so it is a prime number. We write here, since 37 has only 2 factors, therefore 37 is a prime number. I hope it is very much clear to you. Then we have this number 26. Again we will start by writing the factors of 26. Tell me, what are the factors of 26? 1 is a factor of every number and 26 will be a factor of itself. And are there other factors also of 26? You can see this is an even number, and so we can easily divide it by 2. So let us divide 26 by 2. What will we get? You should also know the tables also, then it becomes very easy. It's 2 13s are 26, and you also know the table of 13. 13 2s is 26. So we have this factor 2 and the other factor is 13. Are there other factors also of 26? For this you will have to think about the tables. Does this 26 appear in any of the tables other than 2 and 13 and 26? No. So these are the only 4 factors of 26. So we can write here, since 26 has 4 factors, Therefore, 26 is not a prime number. It is a composite number. Okay, clear to you? Next we have question number 9. Write 7 consecutive composite numbers less than 100 so that there is no prime number between them. What do you mean by consecutive? Consecutive means continuously. There should be no break in between. So we have to write 7 composite numbers, 7 composite numbers which are continuous. There should be no break in between. Break of what? There should be no prime number in between. There is no prime number in between. So we need to have 7 such composite numbers continuously, one after the other. Let us have a look at these prime numbers from 1 to 100. Let us try to find out the difference between two consecutive prime numbers, and let us see whether we will have 7 composite numbers between them or not. You can see these are very close to each other, 2, 3, 5, 7, 11, 13, 17, 19. Their difference is very small, and so we cannot find 7 numbers in between these two prime numbers, any of these two prime numbers. We move on to 23, 29. Let us have a look at the difference. It's 29 minus 23, 6. The difference is 6. So here also we cannot get 7 consecutive composite numbers because we are having only the difference of 6. If you try to write down, you can start after 23 we will have 24, 25, 26, 27, 28. Just count how many of these are composite numbers. 1, 2, 3, 4, 5. Only 5 consecutive numbers, and we are looking for 7 because after 28 we are getting 29. So here we have only 5. So this is not solving our purpose. So let us erase this. Then we look out for other numbers. Again between 29 and 31, it's a difference of only 2. So it's not serving our purpose. It is in fact these two numbers are the twin primes. Then 31 and 37, again the difference is 6. If you take these two numbers, the difference is 6. Again we will get only 5 consecutive composite numbers between 31 and 37. Look out for these numbers in the 40s. Again they are very close to each other. We will not get 7 numbers continuously. Then we look out between 53 and 59. Their difference is again 6. Again we will not get 7 numbers continuously. If you want to write, you may try. After 53 we will have 54, 55, 56, 57, 58. After this we have 59. So again these are only 5 numbers. Then look out for other pairs. Between 61 and 67, again the difference is 6. This will not help us. 71, 73, 79, these are again very close, and so we will not get 7 numbers continuously. So this will not help. Between 83 and 89, what is the difference? 9 minus 3, again it's difference of 6. So again we will get only 5 numbers continuously between 83 and 89. Then we look out for the difference between 89 and 97. What is the difference? Just subtract. It's 8. 97 minus 89, it's 8. Yes, here we can get 7 consecutive composite numbers in between. What we are looking for? हम ढूंढ रहे हैं 7 लगातार composite numbers between any two given prime numbers. इनमें से कोई भी 2 prime numbers लेके consecutive, we have to take 7 composite numbers in between. And so here we are getting the difference of 8, and here we will get the answer. So we can write 7 consecutive composite numbers are. We will start from 90 because 89 is a prime number. Then we have 90, 91, 92, 93, 94, 95, 96. Then 97 itself is a prime number. Now let us count these numbers. 1, 2, 3, 4, 5, 6, 7. Yes, we are now getting 7 consecutive composite numbers. I hope it is very much clear to you. Then we have this question. Express each of the following numbers as the sum of 3 odd primes. Here we have this number 21. We have to break it up into 3 numbers such that they are odd, they are prime and their sum comes out to be 21. So, we will first break it up into 2 primes or 2 numbers and then we will look for 3 numbers. First of all, let us write it. We should know the prime numbers. You know that the prime numbers start from 2, then we have 3, 5, 7, 11, 13, 17, 19 and so on. All these should be very much learnt to you. Okay. So, these are the prime numbers we are talking about. We have to break this 21 and if we take 2, can we take 2? No, because we have to take only odd primes. So, this 2 cannot be taken here. We start with 3. If we take first part as 3, then what will be the second part? You can subtract 3 from 21. It will be 11 minus 3, it's 8 and 18. Okay. So, the second part will be 18. In this way, we have broken 21 into 2 numbers. Now, this 3 is a prime number, but this 18 is not a prime number. Again, we will break up this 18 into 2 parts. 3 is the first part. Then we have to distribute this 18 into 2 parts. Let us take the second prime as 5. If we take it as 5, then what will be the second part? Clearly, it will be 18 minus 5. And what will it be? 8 minus 5 is 3, 13. So, the third number will be 13. Are these numbers prime? Yes, these numbers are prime. In this way, we have broken this 21 into 3 numbers such that they are odd and they are prime. So, our condition is being satisfied and we have got the answer as 3 plus 5 plus 13. Now, is this the only possible combination of 3 numbers, 3 odd primes in such a way that we get the sum as 21? No, there are other such combinations also possible. You can try other numbers also. Let us try to get another combination. If we take 21 as 7 plus 14, we can write it in this way also. We have taken the first prime as 7 here and then the second number will be 14. When we subtract 7 from 21, we will get 14. Now, we will break this 14 into 2 parts. How can we break it? Just think about it. Can we write 14 as 11 plus 3? Yes, why not? And now again we have got 3 prime numbers which are odd and their sum is coming out to be 21. So, in this way not only one, we can have many combinations of different odd primes getting the sum as 21. Then we have the second number which is 31. Again we have to break this 31 into 3 different numbers odd primes. हमें इस 31 को 3 नंबर्स में डिवाइड करना है, तोड़ना है, पार्ट्स करने हैं इसकी इस तरह से कि वो ऑड नंबर हो, प्राइम हो और उनका सम 31 हो. सो वी टेक अप 2 पार्ट्स फर्स्ट. हम पहले इसे 2 पार्ट्स में बांटेंगे. पहला प्राइम, लेट अस राइट द प्राइम नंबर्स वंस अगेन so that it's very much clear to us. 2, 3, 5, 7, 11, 13, 17, 19 and so on. 2 can't be taken here because it is an even prime and we have to take odd primes. So, 31. We will start with 3. What will be the second number that is possible? Subtract 3 from 31. What will you get? You will get 28. Now this 28 is not a prime number, but now again we will break this 28 into two parts. What can they be? First number, let us take it as 5, and then the second one will be 28 minus 5, it's 23. Yes, now we have got three numbers, three odd primes such that their sum is coming out to be 31. It's okay. Now you can get other combinations also, and that I leave it up to you. Then we have another number 53. Again we have to write it into three numbers such that they are odd and prime and their sum is 53. So let us try to do this. The first number that we can take is 3, and then what will be the second number? Clearly it will be 50. Now let us try to break this 50 again into two parts. 3 is the first number, and if we write 50 taking up 5 as the second number, then the third number will be 45. If we subtract 5 from 50, we will get 45. So first number we have taken 3, and then the second 50. Now we are breaking 50 into two parts, 5 and 45. But now here, is this 45 a prime number? No, it has other factors also besides 1 and 45. It is divisible by 3, 5, 9, and so it has many more factors. So it is not a prime number, and we cannot take this combination. So we look out for another combination. If we take the next prime, which is 7, then what will be the third number? Just subtract 7 from 50, it comes out to be 43. So the third number is 43. Now is it a prime number? Yes, 43 is also a prime number. 7 and 3 are clearly prime numbers. So we have got three prime numbers, odd prime numbers, whose sum is 53. We have one more number, 61. Again we have to break it into three numbers. First we will write it as, let us take the first number as 3, then the second number will be 61 minus 3, it will be 58. Now let us try to break this 58 also into two parts. If we take it as 5 as the first one, then what will be the second number? Just subtract 5 from 58, you will get 53. So 53 is the third number. Are these three numbers prime? Yes, 53 is also a prime number, 5 is also a prime number, and 3 is also. So we are having three prime numbers, odd primes, whose sum is 61. Other combinations are also possible. Let us try to get one more combination. We can take it as 7 plus, what will be the second number? Just subtract 7 from 61, it will be 11 minus 7, 4, 54. Now this 54 needs to be divided into two parts. 54, if we take one of the number as 11, then what will be the second number? 54 minus 11, just subtract 4 minus 1 is 3 and 5 minus 1 is 4. Yes, 43. Are the three numbers prime? Yes, they are. So we have got another combination of three odd prime numbers whose sum is 61. Similarly, you can look out for other combinations also. Then we have question number 11. Write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. We have to write 5 pairs. Pairs means taking up two numbers at one time. We have to take two prime numbers such that when we add them, then the sum is divisible by 5. हमें दो प्राइम नंबर्स ऐसे लेने हैं कि अगर हम उनको ऐड करें इस तरह से, तो जो आंसर आएगा सम वो 5 से डिविजिबल हो, 5 का डिवीजन पूरा पूरा जाता हो. जैसे 10 में 5 को डिवाइड करेंगे तो डिवीजन विल बी कंप्लीट, इट विल बी 2. सो वी आर लुकिंग फॉर टू प्राइम नंबर्स whose sum will be completely divided by 5. First, let us write down the prime numbers less than 20. Prime numbers less than 20. By this time, I hope that all of you must have learnt these prime numbers at least till 20. They start from 2, then 3, 5, 7, 11, 13, 17, 19. These are the prime numbers less than 20. We have to join or add two numbers such that we get a number which is divisible by 5. Now, which numbers are divisible by 5? The numbers which are multiples of 5 will be divisible by 5. Let us write down the multiples of 5. They are 5, 10, 15, 20, 25, 30. All these numbers are multiples of 5. And what is special here is that the digit at one's place is either 5 or it's 0. So, whenever we will be taking up two numbers, the digits at the ones place should either end up at a 0 or at 5. Okay? So, we take up the first pair. Required pairs, we can write in this way. The first one. Let me take the first number as 2. Now, I need the sum to be either 5 or 10. If I add 3 to it, what do I get? Taking up the first two numbers, I get 5, and yes, it's very much divisible by 5. 5 ones are 5. You can see. So, we got this first pair. Now, we look out for the second pair. Now, I want to get 10. If I add, what number should be added to 2 so that we get the sum as 10? It should be 8. 8 plus 2 is 10. But now, is this 8 a prime number? We should have a prime number. Both the numbers should be prime. But 8 is not a prime number. So, we cannot add in this way. Let us take some other number. Let us take 3. Okay. And now, what should be added to 3 so that we get the next number, the sum which is divisible by 5. So, if we add 7, we will get 10, which is clearly divisible by 5, but this we already have been given in the question. So, we will not take this number. Okay. We will not take this number, this pair. Then we look out for some other pair. If we add 3 and 17, now what will we get? 3 plus 17. What we are getting? It's 20. Yes, now it's very much divisible by 5. And so, this is the second pair that we have got. Then we look out for the third pair. What can be the third pair? Clearly, you can see that if we add 7 and 13, again we will get 20, and that will be divisible by 5. So, we can write the second or the third pair as 7 plus 13 equal to 20. It will be again divisible by 5. What other combinations are possible? Just think about it. Now, we will write the fourth pair. We need to get a 0 or a 5 at the end. We have to add in such a way. Again, just have a look. If we add this 11 and 19, 1 plus 9, we will get a 0 at the back, 10. 1 plus 9 is 10, and now we will get a 0, and then it will be divisible by 5. So, let us try 11 plus 19. What is it? It's 9 plus 1, 10, and 1 carried, it's 30. And yes, 30 is very well divisible by 5. So, we got this fourth pair. Now, we look out for the fifth pair. Again, just have a look. If we add 2 and 13, what do we get? 2 plus 13. It's 15. Yes, and now 15 is divisible by 5. Okay. And similarly, if you add, we have more numbers but then they are greater than 20. So, we are having these combinations and you can look out for more such possible combinations. Okay. Then we have this question number 12. Fill in the blanks. A number which has only two factors is called which number? Only two factors. Yes, it's a prime number. We have already discussed again and again that a prime number has only two factors, and which are those two factors? 1 and the number itself. So, a number which has only two factors is called a prime number. Okay. A number which has more than two factors is called a composite number. A composite number has more than two factors. That also we have discussed again and again, and so it will be a composite number. 1 is neither a prime number and nor a composite number. You should always remember this, that 1 is not included in the prime numbers also and nor in the composite numbers. So, we write here 1 is neither prime nor composite number. Okay. Then the smallest prime number is which number? We know that the prime numbers start from 2, then 3, 5, 7 and so on. So, which is the smallest prime number here? Obviously, it is 2. So, the smallest prime number is 2. The smallest composite number is, now we need to know the composite numbers. We know that 1 is neither a prime number nor a composite number, then 2 and 3 both are prime. So, the composite numbers will start from 4, then 5 again is a prime number, 6 is the next composite number, 7 is again prime, then 8 is the next composite number, 9, 10 and so on. So, which is the smallest composite number? It's 4, and so we can write here 4. Then the smallest even number, it's 2. You all know that even numbers are the multiples of 2, and so even numbers are 2, 4, 6, 8, 10, then 12 and so on. So, the smallest even number is 2, and so we have written here 2. With this, your exercise 3.2 is complete. In our next class, we will be discussing about some divisibility rules. Till then, keep watching.